Now that we know how to add and subtract similar rational expressions, we can now move on with how to add and subtract dissimilar rational expressions. But before we learn this one, it is a must that we learn first how to find the least common denominator. Here are the steps in finding the least common denominator, or the LCD of rational expressions. Let me give you an example to demonstrate these steps. Consider the example, find the LCD of the given rational expressions. Take note that in this example, we will only be dealing with the denominators. So the first step is to factor the denominators. Considering the first denominator of z squared plus 2z plus 1, we factor this in two ways. We can factor this as a type 1 trinomial, or a lot faster, we can factor this using perfect square trinomials. Z squared plus 2z plus 1 can be factored as z plus 1 times z plus 1, or we can have it as z plus 1 quantity squared. Taking a look at the second denominator now, z squared minus 1, we factor this using the difference of two squares technique. So z squared minus 1 can be factored as z plus 1 times z minus 1. The next step is to get the common factor or factors between or among the denominators. So we see that z plus 1 is a factor that is common to both denominators. We always make use of the highest exponent. So between z plus 1 to the first and z plus 1 raised to the second power, the highest exponent is 2. So for the common factor, we take z plus 1 quantity squared. Third step is to get the not common factor or factors. As always, you make use of the highest exponent. Taking a look at the factored form of the denominators, we see that z minus 1 is a factor that's present in z squared minus 1, but it's not present in the first denominator. So we say then that z minus 1 is a not common factor. We take that factor, and as always, we make use of the highest exponent. Fourth step is to multiply the common and the not common factors. Or simply put, we put together our answer for steps 2 and 3. The LCD therefore is z plus 1 quantity squared times z minus 1. Example number 2. Find the LCD of the following rational expressions. For letter A, we don't need to worry about factoring the denominators because the denominators are already given in factored form. So we now identify what is or what are the common factors. Taking a look at the denominators, we see that x minus 2 is a factor that is present in both rational expressions. We make use of the highest exponent, which is 2. Therefore, the common factor is going to be x minus 2 quantity squared. Then next, we identify the not common factor or factors. We see that in the first denominator, there is a factor of x, but in the second denominator, there is no factor of x. We then say that x is a not common factor. Multiplying the common factor and the not common factors, then we would get the LCD, which is going to be x times x minus 2 quantity squared. Next, letter B, we don't have to worry again factoring the denominators because it's already in factored form. So we move on with finding the common factor or the common factors. Looking at the denominators, y minus 2 is a factor that's common to both denominators. So we pick y minus 2, and as always, we make use of the highest exponent. Between 2 and 3, 3 is the higher exponent. So what we use for the common factor is y minus 2 quantity cubed. Y plus 1 is also a factor that's common to both denominators. So we also pick y plus 1 and use the higher exponent, which is 3. There are no other factor that is common to both the denominators. So we move on now with identifying the not common factor. In both of these denominators, we would see that there is a factor of 4 in the second denominator, but we don't see it in the first denominator. So we say that 4 is a not common factor. Combining the common and the not common factors, we then get the LCD, which is going to be 4 times the quantity y minus 2 cubed times y plus 1 quantity cubed. Letter C, there is a need for us to express the denominators in factored form. So let's start with m squared plus 6m plus 9. This is a trinomial which can be factored either as a type 1 trinomial, or I hope you see that this trinomial is actually a perfect square trinomial. So the factored form of this is m plus 3 times m plus 3, or we can condense that as m plus 3 quantity squared. For the second denominator of m cubed plus 27, this is going to be the sum of two cubes. So the way we factor it, it's going to be m plus 3 times the trinomial factor of m squared minus 3m plus 9. Now that we have the factored forms of the denominators, we can now move on with the next step on finding the common factor or the common factors. The common factor, we would see that m plus 3 is common to both denominators. So we choose m plus 3 and we take the higher exponent, which is 2. There is no other factor that's common to both denominators. So we move on with the next step on finding the not common factor. The not common factor for both of these denominators would be m cubed, or rather m squared, minus 3m plus 9. Combining the common and the not common factors, we then get the LCD, which is the quantity of m plus 3 squared times the quantity m squared minus 3m plus 9. Your turn now. Answer exercise 7.04 in Schoology.